Hello, Internet. So today I want to talk about what WebAssembly is exactly. Because I have this compiler, C compiler, and a single file that compiles down to WebAssembly, right? So what is WebAssembly? Well, WebAssembly is this, and it's this, right? So a WASM file, when you look inside it, is made up of multiple sections like this. I guess the section is broken up into functions, and then each function has instructions to run when you do something. And you actually could set things up so that when the program quote unquote starts, it could be any one of these functions. But in my setup, it starts in main. I have a little hello world example here. You see that this number here, 68032, corresponds to a pointer containing the string, right? Like you kind of, if you learn C, this is kind of what you understand, that pointers are actually just addresses or numbers into wherever the string is. Here you have another one to the string world. You have function puts. There's a call instruction, right? So the code turns out to be quite clean. And if you, but you kind of see how loops are done, right? Local variables. There's an instruction for setting the value. Like you first have to set up the value on the stack. And another cool thing is that the debugger is also built in. So in theory, you can just step through the program. So this is what the file is made up of, right? Like it is a binary file, and it's encoded in a certain way with these different sections. And then the section has what global variable. Like the WebAssembly contains logic for doing things, but it can't actually write to the screen. That has to come from the runtime somehow. So in this case, the only thing this thing does is print something to the screen, and so the only thing you really need is the write function from the host. But a lot of these sections, you just declare that a thing exists, right? Like memory exists, a table exists, and then the most interesting section is the code section. That's where the actual code lives for each function, right? So for example, the function section declares a list of functions that you're going to define in this, right? It's not like magic, right? Like you see, oh, okay, you have a list of functions, the functions describe, right? So architecturally, what is WASM and why does it exist? The reality is the vast majority of programs in the world, they're written in C or C++. File your source files into executables, right? Like an exe file. And then that exe file, it can't actually run on its own. It needs to be hosted somehow, right? You can have a program that you've compiled for x86, but that doesn't mean that your program can actually run on any x86 computer. That computer needs to have an operating system that knows how to run this. Operating system development can be kind of hairy, but unless you are writing an operating system or writing for an embedded system, you will almost always be writing programs for a hosted environment, right? CPU architecture, the CPU architecture gives you enough to write logic in that binary, right? Like x86 has a certain way of encoding instruction for saving to memory, reading from memory, writing this bit of data. How those system calls are interpreted, the protocol on how to call functions and stuff, that actually tends to be kind of in the domain of operating systems, right? So in order for that ability, if you have a program that wants to say, hey, I want to read a file, or I want to print to the screen, or I want to get a keystroke from the user, that that is not an objective, that kind of thing is not universal. There needs to be a protocol that's agreed upon. How do you ask for a keystroke? How do you ask to write something on the screen, right? So that is negotiated with the operating system. Keeping that in mind, right? When the browser came along, when people wanted to run stuff in the browser, programs written in C and other languages that they want to run in the browser. But the browser can only run JavaScript. So what do? It's basically similar, except that instead of an exe file, basically you have JavaScript, like JavaScript HTML, right? Basically you need to write in a format that your platform understands. And traditionally, the browser only understood JavaScript as the executable platform. People realize that you could take a subset of JavaScript and they could kind of act as the building blocks of assembly. JavaScript actually could serve that role as well. And so for a while, people actually had a subset of JavaScript they used, which were especially optimized by browser vendors, right? So when they recognize that your entire JavaScript program was actually this subset, they would actually optimize just that. But like JavaScript turns out to be a terrible language, you know, for being assembly, because it's not, JavaScript is not meant to be assembly, but people were kind of hacking it and using it like it was assembly. So eventually people realized that it might be great if we had, instead of using JavaScript, we had a specialized binary format. Just like we have for exe, like what if we had a special binary format? For Flow is not that different, right? You write a C program, you compile it for an architecture and operating system, and then you run it on that architecture and operating system. Well, like for WebAssembly, instead of x86 or ARM, your architecture is WebAssembly. Like this is the instruction set, right? The ones that we just saw earlier. And then instead of like Windows or Linux or Mac as operating system, the OS basically became, like the browsers became the OS. And the fun thing about having the browser be the OS is that every operating system has a browser, right? So effectively this means that any program that targets WebAssembly and browser can run on any operating system. And there are some restrictions in WebAssembly for security-related reasons that are just not available in x86 or ARM, like you can't jump to arbitrary labels in WebAssembly, which makes it kind of annoying to implement go-tos in C. And that could be its own video at some point, but hopefully this makes it kind of clear what WebAssembly is.